So now take out your handout, the one for analysis of variance. Want us to do the Anova. Analysis of variance. It's under that handout. We have the application of regression analysis. That handout. So open that. Alternative for this with the handout, I have them separate. That's handout page 37. Handout page 37. So hoping you have the notes. So let's start with the first page. We have the application of regression analysis. You go through that. Also on how do we test the reliability of the equation. So Anova analysis is under cost forecasting or forecasting and correlation. And I showed you on how to develop using the simple least square method and multiple regression, where you have an equation, for example, y is equals to a plus bx. And in case you have a multiple regression equation, it's a plus b1 x1 plus b2 x2. So how do we test the reliability of that equation? That the equation we'll be using here to forecast is reliable. So now let's look at that. Testing the reliability of the equation. And when testing the reliability of the equation, these are the procedure or tests undertaken to assess the accuracy of the equation before it's adapted as a general forecasting tool. And the test focuses on three main areas. One is the economic plausibility. We say that economic plausibility, that means, is that equation making economical sense? So when it's making economical sense, we say that it's plausible. But when it's not making economic sense, we say that it's spurious. Good. Then we have the goodness of it. How well can it fit? And then the assumptions. We want to look at the assumption of linear regression. Which are they? Linearity, independence of dependent variable, independence of dependent variable, normality, zero mean, homoscedasticity, all that. So now let's start with A, economic plausibility. For economic plausibility, this is about testing whether the perceived relationship is logically defensible and economically sensible. If the relationship is logically defensible and makes economic sense, it is said to be economically plausible. If the relationship is not sensible, therefore you cannot defend it. It's not defensible or does not make economic sense. It's referred to as spurious or nonsensical. Good. Then I showed you on how to test the goodness of it. And the goodness of it, we did correlation coefficient to test the strength of the relationship. We also did coefficient of determination. How is the dependent variable explains the independent, or how is the independent variable explain the dependent variable? So goodness of fit can be made using the following method. One, coefficient of determination. How do you say it was the same as coefficient of determination? Can you write in bracket? It's also known as explanatory power. Explanatory power. Explanatory power. Yeah, it shows how one variable explains the other. Then number B, the standard error of estimates. Then we have the F distributions, correlation coefficient, that's R. Also the standard error of the slope, and then Z or T distribution. We'll come and discuss that. So you have some illustration given there, so that's something you can be able to follow. Something you can be able to follow that. Now I want us, now we go to page 5 of that handout, where you have now the analysis of variance. Yeah, that's what we call Anova. Where we have the analysis of variance. Now, if I explain what's analysis of variance, Sometimes when you're having more than one independent variable and you need to generate a forecasting equation, let's assume you have 3 independent variables. That means when coming up with a forecasting equation, your equation will be y is equals to a plus b1 x1, b2 x2, b3 x3. Also, in some circumstances, we may have even 10 independent variables. So in that case, there is what we call a statistical software, which can be used to analyze that information. So you as an accountant, the software will do everything for you. So it's upon you as an accountant now to interpret. So analysis of variance is all about interpretation of a computer-aided software on regression. Are you together? Yeah. So in this case, we are not mostly computing. It's all about interpreting. So these are computer-aided analysis of regression analysis. Interpretation is done as follows. So me, I don't want you to cram anything there. If you have your past paper, open your past paper. Or if you have that handout, the same, I have indicated that question. June 2010 question 3. June 2010 question 3. If you have the past paper, you can open that question. In case you don't have that past paper, go to page 6. I have that question typed there. June 2013 question 3. June 2013 question 3. June 2010 question 3. Part A of the question was outlined for assumption of linear regression model. What are those assumptions? Let's be quick. That's what I have mentioned just some few minutes ago. Linearity. Let's go to part B. A mortgage company intends to develop a model to be used to predict the number of loans issued by the company. Are you together? To predict the number of loans issued by the company. So you already know what is our dependent variable. What do we want us to forecast? The company has collected data on the number of loans issued by the company over a 10-year period. Can you underline 10? So that means our n is equals to 10. The data has been processed using a computer software and the following results generated. So we have the variables, model, we have variable entered. How many variables are entered? We have here interest rate and income. So those are what we call the independent variable. They carried an analysis based on the year, interest rate, and income. How many independent variables do we have? There are 3. Can you write somewhere? 3. Good. Then we have the model summary. Model summary. We have R. R present what? Hey, R presents what? This is something we have already done. Eh? We said R present what? Is it not correlation coefficient? Yes. Good. That's correlation coefficient, of which in this case we have 0.972. How can you interpret that? I'm telling you that this information is generated by a computer. It's upon you to interpret. Are you together? So in this case, we have 3 independent variables: year, interest rate, and income. And in this case, the correlation coefficient is 0.972. Who can interpret that for me? Yeah, I'm not teaching. I'm just revising this word called blocks. How do you interpret correlation coefficient? That means there is a strong positive correlation. Then we have R squared. What's R squared? Good. Coefficient of determination. How do we interpret that? Good. We are 94% sure. Or you can also say that 94% of those independent variables, year, interest rate, and income, good, explains the number of loans issued. Remember, in this case, we are carrying out a forecast to determine the number of loans issued by the company. So we can say that if R squared is 0.944, 94.4% of the or you can say that 94% of the number of loans issued is being explained by year, interest rate, and the income. Then you have adjusted R. Now adjusted R is just R squared, and then you take some standard errors, and then we have SE, that's standard error of estimate. You know, I'm not going to repeat this. It's better kindly, if you get a point, kindly write it in that your handout, or just listen to it. Now let's go to the most important table. Can you go where you have Anova? Can you see Anova table? Anova table. Anova table, you have model, and then we have three models. We have regression, residual, and total. Then the first one you have is sum of square. Now let's be here. Sum of squares. And we have how many sum of square? We have three sum of square. One is the regression sum of square. Then we have residual or error sum of square. And then we have total sum of square. Now let's be here. Now let's be here. Now regression sum of square, that's what we call explained variation. Regression or error sum of square is what we call an explained variation. You don't have to write this. The first page I have just, it's already explained there. Then we have total. Total sum of square is what we call or total variations, of which to get the total variation, if you take regression, you divide by residual sum of square, you should get total variation. Are you together? If I may take you back. We say that how do we get coefficient of determination? How do we get R squared? R square, R times R, right? Or I give you another formula. Who can remember? You can just confirm. Just confirm. We said, how do we get coefficient of determination? Explained variation divided by what? Total variation. That's how we get the coefficient of determination. Good. Now I want us to try the same. We have said that, let's be here, that regression sum of square is the same as explained variation. Residual is an explained variation. Total SS is the total variation. So you want to get the collision coefficient of determination. You take the explained variation. How much is explained variation? So in this case, you will take explained variation, you are taking regression sum of square. That's what to present the explained variation. You divide by the total sum of square. How much is regression sum of square? I mean, yeah, regression, not residual. We are given 1357,13208.88. You divide by the total of 14,371,5486.4. Can you do that? Do that. You are getting 0.944. 0.944. Now, can we go back to the first table? The model summary. At the model summary, we have R squared. How much is R squared? We are given a 0.9444. That's how we get that. Good. Now stop writing. I write everything here on summary, and then I'll give you time to take your summary. But you cannot listen when you're writing. I'll give you time. Now let's go to number 2. We are through with the sum of square. We are in Anova table. What else do we have? Can you see DF? DF, that means degrees of freedom. Have you ever heard of degrees of freedom? When you're doing which topic? Hypothesis testing. Yeah, degrees of freedom. So DF, that means degrees. And then we have total DF. So what does it present? Now let's be here. Regression DF present the number of independent variables. Number of independent variables. So if you go to the first model, how many variables do we carry the analysis of? We had here interest rate and income. How many independent variables? 3. Now can you go to your DF? Regression DF. Ningapi? Is 3. Then we have residual DF. How do we get residual DF? Residual DF is N minus K. And how do we get total DF? Total DF is N minus 1, which is the same as regression DF. You add residual DF, you get the total. What is N? N means the sample size. Are we together? Or the number? What about K? K means computed parameter. Computed parameter. What do I mean? If you have an equation like this, y is equals to a plus b, x. In this case, our k is 2. A and b. Are we together? So k is 2. If you have this equation, y is equals to a plus b1 x1, b2 x2 plus b3 x3. Our k is how much? Our x is? Our k is 4. Yeah, in short, is the number of independent variable. You also add the constant. Are you together? We have x, b1, b2, b3, and then we had the constant of a. You get how much? 4. Now let's go back here. Residual DF. You take n. How much was our n? 10 period. Good. 10 minus. How many independent variables do we have? 3 plus the constant. Therefore, k is how much? 4. 10 minus 4, you get 6. Can you confirm if you are regression DF? I mean residual DF. Is it 6? That's what you're given, 6. Then total DF, you're saying that is n minus 1. Our n was what? 10 minus 1, you get 9. Can you confirm if your total DF is 9? Is that 9? Yes. And if you take both regression DF plus residual DF, you should get the total DF. Good. What else do we have? We are through the DF. We are analyzing the, I'm showing you on what does the item in the Anova table represent. So you're through the DF. What else do we have? Mean square. Good. We have mean square. Mean square. And we have only 2 mean square. We have regression mean square, and we have residual mean square. Now let's be here. How do we get regression mean square? You just take regression sum of square, you divide by regression degrees of freedom. How do we get residual mean square? You take residual sum of square, you divide by residual degrees of freedom. Now I want us to do that. Let's start with the first one. Can you see regression mean square? How do we get that? We are saying that you'll be taking sum of square, you divide by degrees of freedom. So in that case, can you take 1357, 1328.88? You divide by its degrees of freedom, which is 3. Divide by 3. Are you getting what you are given there? You get? Are you getting the same? Now, can you try also for residual? Residual do the same. You take residual sum of square, you divide by residual degrees of freedom. That will be 827.52. You divide by 6. Is it the same? Yes, good. Are you good up to that point? Then number 4, we have F. Can you see F? Now that's what we call F calculated. And how do we get F calculated? To get F calculated, you'll be taking regression mean square, you divide by residual mean square. That's how you get F calculated. You take regression mean square, you divide by residual, residual mean square. Let's try that. Can you take regression mean square? That's 45, 23, 77, that's 6. You divide by 1333, 712.92. Are you getting 33.91? Is it adding up? Good. And then we have F significant. Can you see FS? Number 5, in the same table, we have F significant. It's also what we call F critical, and that one you read it from F tables. F table. At the back of your past paper, we have both F table, T table, Z table. That's what you get from that table. Good. I have not said you go that to the past paper. We'll come to that. Are we through now with the analysis of variance table? Let's go to the other table. Table number 4, coefficient table. Coefficient table. And a coefficient table, we have model, then we have those variables. The first one is constant, income, interest rate, and year. Then we have unstandardized. And unstandardized, can you see B? Yeah, B is also known as the estimates or the coefficient. Then we have standardized error or standard error, SB. Standard error, that's our SB. Then we have beta. Then we have T. Can you see why we have T? Now that's what we call T calculated. And how do we get T calculated? To get T, you'll be taking B over SB. Coefficient over the standard error. Are you together? So for example, in the same table, let's try to do for, can you see the income? Let's go to income. Let's compute T for income. You're already given, We want to justify that. We are saying that to get T, you take B over SB. Give me B for income. 67, 72.23. You divide by SB. Its standard error is how much? 67, that's 2.138. Can you compute that? You're getting 1.006. Can you confirm this? That's what you have in your T column. Is that the same? Yes. So, and this is an important formula you need to note, that to get T is B over SB. And then after T, we have what? Can you see? Sig. Sig means it's T significant. And this is what you used to read from the T table. I showed you how to read the T table when you are doing hypothesis testing. So it's also known as T critical, and you read it from the table. Good. I want to give you 2 minutes to take a screenshot. For those who can be able to copy within the given time for 2 minutes, can have that. Actually, this is all about Anova. You can either understand or cram it, because haina another option ya understand kama utashikia hapa. 2 minutes. Good. So now I want us to answer that question. Let's go to the required. I was showing you on how to interpret. Now with the interpretation, you can be able to answer. So you can also follow that question in the handout. Now let's read the question again. Read the question again. That a mortgage company intends to develop a model to be used to predict the number of loans issued by the company. The company has collected the data on the number of loans issued by the company over the 10-year period. The data has been processed using a computer software and the following results generated. So you have that. Now let's go to the required. Let's go to the required. The values represented by data X, Y, and Z, 6 marks. Which table is that? It's from the coefficient table, right? Now, whenever you see that from the coefficient table, what comes to your mind is how to get T. How do we get T? To get T, it's B over SB. So we need to get X, Y, and Z. Now let's start with X. X, what is required in that case? It's B. This is what we need. Are you together? That means you're already given T. Give me T. Negative 0.125 is equals to B. You divide by SB. Are we given the SB? Yes. SB is 25,478.47. Can you be able to get B? To get B, you take that minus that. Eh? No. I'm saying what? C cross multiply. Yes, is that multiply by that? Eh? I said minus. Ah, so you multiply. So to get B, just take that, you multiply by that. Give it into 2 decimal places or 3, negative. Negative. 8481. Good. Now let's go to Y. We need to get Y. What's Y? Y, they need what? T. Are you together? And to get T, it's B over SB. Do we have B? Yeah, B from that row, it's negative 1683.71. You divide by SB. SB is 885.741. Get negative 1.9. And lastly, we need to get Z. What is Z? Yeah, the requirement is SB. So that means we must be having T. HT is how much? T is negative 0.44 is equals to B. HB is how much? Negative 372.291. Then you divide by SB, of which that's the Z. So how can we do that? If you just cross multiply, that means you multiply by SB, then you divide both sides by this, right? Yeah, so you'll be taking negative 372.291, you divide by negative 0.444, and the negative disappears. 8.49 to get your 6 marks. Good. Let's go to number 2. Number 2, kindly don't copy. You can't listen as well as you copy for Anova. Number B is the model to predict the number of mortgage loans issued by the company. The model. What do you mean by model? Model means what? Model means in equation. Are we together? Yes. So in this case, how many variables do we have? Independent variable do we have? That means our equation will be y is equals to a plus b1x1, b2x2, b3x. There is something I indicated. What does B indicate? It's the same as coefficient. Can you go to the coefficient table? Can you see where you have B? Yeah, B are the coefficient. So it will be like this. Y is equals to A. A means what? Constant. Do we have B for constant? It's X. Are we together? But we have already computed our X. And our X was what? Yeah, negative 3184.81 plus B1X1. Do we have B1? That's for income. It's how much? 6772.23x1 plus, yeah, or you can write, yeah, plus minus, or you can just write minus, negative 1683.71x2 plus negative 372.29 x3. Yeah, in short, use the coefficient or the B to get the model. Are you together? Yeah, that's how you develop the model. And how do we interpret the model? How do we interpret the model? Now let's be here. Because in some cases you'll be told that, can you interpret the model? In this case, our A is how much? Negative that 180. What are you predicting? Yes, I know it's Y. Eh? What does Y represent in this case? Can you read the question again? The model to predict the number of mortgage loan issued. Are you together? So in this case, our Y is the number of mortgage loan issued. Are you together? A is the constant. Now, how do we interpret this? Kind of reason. Eh? This is A. Are you together? So this is the decrease in the number of loan issued due to other factors, not in the model. What is X1? Was income. Are you together? Which is positive. Are you together? Positive means is an increase. So this is the increase. That means 6772 is the increase in the number of loans issued by the company when income increases by 1 unit. Are you together? I pardon. Understand the second one. The third one, X2. What is X2? Interest. Are you together? But in this case, it's minus. Are you together? So this will be, this is the decrease in the number of loans issued by the company when interest rate increases by 1 unit. Oh, yeah, I know you're good. Now let's go to X3. What is X3? Is the years. Are you together? Which is negative. Are you together? So that means this is the decrease in the number of loans issued by the company when the number of years increases by 1 unit. Good. So in short, for the variables used, we have some which are significant, others are insignificant. Are you together? I'll come show you how to interpret that. Yeah, so Now we have answered number 1, we have answered number 2. Now let's go to number 3. Let's go to number 3. Actually, Anova carries a lot of marks and usually takes the shortest time possible. It's something you can be able to answer within 5 minutes, provided you know what you are doing. Eh? So number 3, the independent variables, if any, that may not be useful in the predictor model. Explain your answer. The number of independent variables. How many variables do we have? 3. So you bring your variables, and the first variable is income. We have the interest rate, and we have the year. Now, what do we use to determine the suitability or the usefulness of the model? We use T. So you compare the T calculated against T critical. Then we comment, and then we interpret. Now let's go to the T calculated. We said what is T calculated? Where you have T. Are you together? Yeah, T. For income is how much? 1.006. Now I'm taking you back to hypothesis testing. There is correlation between hypotheses. Eh? Then we have interest rate. We have interest rate was Y, and we have already computed Y. Y was negative 1.9. Then we have years, negative 0.444. Let's go to T. And if whenever you're not given, in this case, we're given the T critical. Can you see where you have significant? Yeah, after T, we have significance. That's what we call T significant. Can you write that? It's the same as T significance or T, T critical. T critical, that's from the table. Yeah, that's the figures they wrote from the table. Eh? For income is how much? 0.353, 0.106, 0. And then the T critical, the one we read from the table, remember it's a two-tailed test. So it can either be positive or, yeah, let me take you back to hypothesis testing. And this, whenever you're not given T, this is how you compute T. Eh? To get T critical, you'll be taking alpha over 2. Do you remember that? And then to get the degrees of freedom, you'll be using N minus K. And what is N minus K? Just confirm. It was 6. Yeah? That's what we call residual degrees of freedom. So if we have our T, we accept the null hypothesis. Here we do what? We reject. Here we reject. Now, I want you to note something here. When we're conducting hypothesis testing for T, this is how the null hypothesis looks like. Null hypothesis, alternate hypothesis. So I'll come to explain that later. We are saying that, for example, for T1, I mean for income, the critical is 0.353. It can either be negative or what? Positive, 353. We want to determine whether to accept, whether to reject. Now let's be here. We want to comment here. Our T critical, it's positive or negative 0.353. But our T calculated is 1.006. So now our T calculated is 1.00. Does it fall in between acceptance or rejection? So that means we do what? We reject. T critical for interest rate is 0.106. But our T calculated is 1.9. That's 1.9 lies in between or is outside. So what does it mean? Accept or reject? Reject. Then the one for the years, the T critical is in between, plus or minus 0.673. And the calculated is negative 0.44. Does it fall in between or outside the reject? In between. We accept or reject? Accept. So now we need to interpret. Let's read the question. What's the question asking? The dependent variable that may not be useful in the predictor model. We are saying that T is used to determine which of the variable are significant or insignificant. If we reject, is it significant or insignificant? Very good, significant. Reject, significant. Accept, insignificant. Are you together? We said that we have null, I have alternate hypothesis. We say that the null hypothesis is to formulate to cast the doubt, and you have casted the doubt. If you reject, the truth is the opposite. Are you together? First of all, you rejected, but the truth is what? You're supposed to accept. Or now let me make it clear for you. When you're conducting, it's already in your notes. When conducting hypothesis testing for T, the null hypothesis is that they are all variable X is insignificant. Sorry, it's significant, not significant. Significant. And then alternate is the variable X is insignificant. Is that the case? Sorry, it's the opposite. Yeah, variable X is insignificant. First of all, it causes the doubt. Are you together? That the relationship between the variables is what? Insignificant. Are you together? Then the alternate, it will say that is the relationship is what? Significant. So what do we mean? If we reject, if you are rejecting the null hypothesis, that means we accept the alternate hypothesis, which is, or that's why I knew that you have to cram that. Can you go back to the notes? I have explained that bit by bit. Now let's go back to page 5. Let's go to page 5. Not from the handout, from the notes. From the notes. Then I had shared the notes with you. Or if you're using the handout, we are following the notes and the handout. This one I did not indicate in your handout. Yes, it's not in the handout. You go to the notes. I have provided the notes on analysis of variance. You said that you print them in advance and share them to the group. That's why I have indicated that. Page 5, are we there? Where you have the analysis of variance. Are we there? That's why I give the explanation. What is sum of square, degrees of freedom, mean sum of square, the table of coefficient, what does it represent? Can you see where you have NB? NB, number 1, T test. That's what we are conducting. Shows whether the equation or the independent variable is significant or insignificant. That's what we are doing here. Number 2, or the decision on hypothesis is done as follows. Null hypothesis is that X is not a significant determinant of Y, but alternate is what? X is a significant determinant of Y. Now let's repeat again. Null hypothesis says what? X is not a significant determinant of Y. So that means, now let's be here. If you accept, so what's the null hypothesis there? If you accept, that means X is not a significant determinant of, that's why you're saying it is insignificant. If you reject the null hypothesis, what does it mean? This is when you accept the null hypothesis. Are we together? If you reject the null hypothesis, that means you accept the alternate hypothesis. So if you reject, commercially you are taking the alternate hypothesis. And what are the alternate hypothesis states? That X is a significant determinant of Y. Just read what we have there. Okay. And then I have showed you on how to get the T critical. T critical, you take alpha over 2 n minus k. Then that's the interesting part. IE. What have I explained there? If you reject, are you together? You're reading what you have. If you reject, this means that the model is what? See, that's what I'm doing here. If you reject, that means the model is significant. But when you accept, it means the model is what? Insignificant. Isn't that clear now? That point is idea sana for those who are cramming, but it's better for you to understand. But at this point, I know you cannot understand. So just cram that. That if you reject, now the good thing is that, you see what I'm doing here? When I'll be doing the next question, you might think you have not understood. When I'll be doing the next question, Kama kuna kitu watu wengi watajua ni gani? So don't blame yourself. Good. Now let's go back to the question. Then, sorry. That was number, can you go to number 2? Just below that NB, NB number 2. F test indicates whether the model is suitable. Can you underline that? The same page we are looking where, yeah, F model indicates whether the model is suitable. Can you underline suitable? You have said that if you carry out T test, it's showing where the variable is significant or insignificant. If we carry out F test, it shows where the model is suitable or not suitable. Good. Now we can go back to the question we answered. So number 3, you have answered everything. Number 4, with reference to answer in B3 above, advise the management on the suitability of the model. Is it suitable? Is it not suitable? We have said that for suitability we use what? Good. F. Let's go to Anova table. Anova table. So in our Anova table, it will be comparing F calculated against F critical. Let's go to Anova. F calculated is how much? That's F. That 3 point? Yeah, that 3.91. What about F critical? 0. Okay, if I draw a table for you, whether to accept or reject, this is plus or minus 0. Why is 0? Why is 0? Yeah, plus or minus 0, let's assume is there. Are we together? If you get it's in between plus or minus 0, you do what? You accept the null hypothesis. If it's false outside that, you do what? You reject. Now ask yourself, that 3.91, does it fall in between or outside? Hey, that 3.91, is it in between plus or minus 0 or outside? Should we accept or reject? We reject. It's false outside. Are we together? If we reject, is the model suitable or not suitable? It's very good. The model is very suitable. Yes, maybe measure even. That's how I get you 20 marks. Have you understood? Yes. I want to prove you wrong. If you think you have not understood, I want to prove you what? Wrong. I want to prove that you have already understood. I can't spend all that time trying to explain here. You can't understand. Open with me December 29, question 4. For those without the past paper, but they have the notes, the question is already there. But I shared this question before. I shared in all the groups, twice actually. And I reminded you, kindly print before the next class. So, December 29, question 4. December 29, question 4. So you can take a screenshot of that. Though for those with the notes, it's already illustrated there. I've given already the solution. I'm sure if you have attended my class and they bring a question on Anova, high chances for my students who have attended this. Even if you think you have not understood, you'll score everything. Yes, but how? Let me prove you wrong. December 2009, question 4. A consultancy firm carried out a survey to determine the level of job satisfaction among the employees. Don't just read the question to read. What's our independent variable there? What's our dependent variable? You have to read again now because you just read it. They're saying that a consultancy firm carried out a survey to determine the level of job satisfaction among the employees. So what we are trying to predict here is the level of job, is the job of what? Level of job satisfaction. That's your why. Are we together? Good. Of a given company. A multiple regression analysis was done and the result was shown below. you are given that result. Individual analysis of variables, we have constant x1 up to x7. How many independent variables do we have? There are 7. Are we together? There are 7. Then we have estimate. We said estimate present what? Estimate is the same as coefficient, is the same as B. Are you together? In case you are to come up with a regression model, y is equals to, how many variables do we have? So it will be A plus B1x1, B2x2, B3x3, B4x4, B5x5, B6x6 plus B7x. And we say that to get the model, use the coefficient where you have the b's. Are we together? So the model will be y is equals to A. Y is what? The constant, 13.72 plus negative 0.031x1 plus 0.92x2 plus 0.13x3 plus 0.06x4 plus 0.13x5 minus 0.63x6 plus 1.28x. So that's how we come up with a model. Right together. And in case we have to interpret, we'll come back to that. I showed you how to interpret. Positive means it's an increase. Are we together? So for example, in this case, we say that this is the increase in the level of job satisfaction due to other factors not in the model. First of all, I need to know what's variable x1. If you know what's variable x1, we can say that it's a negative. This is the decrease in the level of job satisfaction when variable x1 is increased by 1 Good. Then we have SB, and then we have standard error. That's SB. Then we have a second table. That's the analysis of variance. That's what we call Anova table. That's our Anova table. In our Anova table, we have the source, regression, residual, and the total. Degrees of freedom. We say that regression degrees of freedom, that represents the number of independent variable. And how many do you have here? Is that 7? Yes. Residual error, we said it's n minus k. N ni ngapi? Good. N is how much? It's not 7. You're not given n, but you can be able to get n. Okay, it's very simple. How can you get n? Because there is somewhere you'll be required to get n. You have said that we have regression sum of square, residual sum of square, and we have total sum of regression. We say that's the number of dependent variable, which is 7. Are we together? Regression is n minus k. And then total is n minus, just go to the total. Total is how much? 40. I want to determine how much was our n. Are we together? So how much was our n? It's 50. It's just 49. You add 1. So that means it was 50. They took 50 minus 1, you get? So n minus k, you'll be taking 50. K ni ngapi? Not 7. If the number of dependent variables is 7, you add 1. 8. And you'll get 40. 42. Is what you're given is 42? Yes. Then you have the sum of squares. We say that, let's start with the first one. Regression sum of square, that presents the explained variation. Residual sum of square, that one presents unexplained variation. And then total sum of square, that one presents total variation. You don't have to cram that. Where now you are given the variable. X1 presents the age of employee, X2 monthly salary, X3 experience, X4 education level, X5 male or female, X6 level of responsibility. Are you manager or not, manager? Then X7 number of years in the service. Required number 8, multiple regression model for the data above. Do you have it? You already have the model. Number 2, interpret the meaning of the variable x1 and x2, x1 and x2. So I want us to explain 3 of them. We start with the constant, x1 as well as x. Let's explain them. And it has how many marks? 2 marks. So constant, give me the value of constant. Okay, what are you explaining? Interpret the meaning of the variable x1, x2, and what are you explaining? Next, you are looking at the coefficient. Are you together? For example, in this case, our constant is 13.72. X1 is negative 0.031. X2, we have it 0. I don't want to write, just reason. Constant, we say that this is the increase in the level of job satisfaction due to other factors not in the model. X1 is negative 0.013. Negative means what? Decrease. So we say that this is the decrease in the level of job satisfaction when X1 presented what? Age of? Yeah, it's the decrease in the level of job satisfaction when the age of an employee increases by 1 year. X2 present what? Mandre? Hey, what do you expect? Okay, what do you expect? This is the increase in the level of job satisfaction when the mandre salary increases by 1 year. Yes, we are motivated. Yeah, that's what you're supposed to interpret. Are you together? Now, can someone interpret for me X6? What does X6 represent? Level of responsibility. Then X6 is negative. Are you together? So it is? What are you saying? Yes, is the decrease in the level of job satisfaction when responsibility increases by 1 unit? 1 unit. Good. Let's go to part C. Test the significance of each variable. Now, when you talk about significance, what comes to your mind? Which test? T-test. Are you together? We use the T-test. How do we get T? Alpha. No. We said T is B over S. Yes, in this case, we are not given. The other question we did, we already given T and also T critical. In this case, we are not given. So how many marks does it have? 7 marks. Test the significance of each variable in explaining the level of job satisfaction among the employee. Use the significance level of 5 marks. You want to determine which one are significant to your model, which one is not significant to your model. So you bring your variables, x1, x2, x3, x4, x5, x6, x7. Then you bring T calculated. How do you get T calculated? B over SB, and then we get T critical. How do we get T critical? Alpha over, of which our alpha is what? 5%. N minus K. And our N minus K is how much? Kama ukumbuki what we say, what is N minus K? Be wrong. So in this case, it's 5%. Are you together? So it will be 0.05 over 2, of which you get 0.025. N minus K. It's already given, which was 42, right? Yes. Actually, you'll be using the residual degrees of freedom. Are you together? Yeah, which is 42. So go to your T table. Go to your T table. Either one tail or two tail test. Go where you have 0.05 or 0.025. Just use any. Either one tail or two tail test. I hope you are using the T test. Iko karibu na where you have the normal distribution curve. 0.025 or 0.05, and then you go where you have the degrees of freedom of 42. Just give me what you're getting. 2.0. Good. That's enough. So 2.021, 2.021, 2.021, 2.021, 1, 2, 3, 4, 5. And then we say that it's either positive or negative since we're using a two-tail test. That's why you're dividing by 2, plus or minus. Now let's get this. T calculated, B over SB. So like the first one, it'll do what? Let's start with variable X1. Its B is how much? Negative 0.031. You divide by SB. Are you given the SB? Its SB is 0.051. For X2, you'll take 0.92. You divide by SB 0.72. So let's be quick. Others do X1, X2, X3, X4. Just give me the answers. The first one is 6.1. One point. The last one is 1.7. X4 0.7. 4. Which one? X5. 0 point. X2. Was this for this for X7, X6, X5? This X4, So X3 2.5. 1. Now let's comment and then we interpret. Now let me draw a T table for you. In this case, we have a T critical of 2.021 negative, 2.021 positive. If it falls within that region, that means we accept the null hypothesis. You reject, you reject. Negative 0.61. Does it fall in between or outside the acceptance or region? In between. Accept, reject. You accept. 1.28. In between. So that means you do what? Accept. 2.51. Outside. We do what? We reject. 0.7. Accept. 0.8. 1.9. 1.7. Accept. Interpret. Is it significant or insignificant? I told you, you have understood. Accept. Insignificant. Reject. Significant. Accept. Yeah. So what does it mean? That means of the research you are doing, of all the variables incorporated in your model, the only variable which is significant to your model, it's only X3. What was X3? Experience. So, you have experience. Do you usually struggle? Now, in this case, we're looking at the job of level of job satisfaction. If you know what you are doing, you don't struggle. Are you together? Yeah. So, of the model we conducted, number one, X1 was the age of the employee. That is insignificant. We have old people who like their job, and we have young people who like their jobs. And the vice versa. What about the monthly salary? Others are not motivated by the salary. Others work for passion, so therefore cannot be what? A significant model in determining then level of job satisfaction. But experience, right together? Experience. So of all the research conducted, the only variable which was significant is what? experience. Education level, I think that one should not apply in Kenya. Should it apply? Just a bit, just a bit for some technical courses. Like what? Like, yeah, like medicine, law, or you can you can present someone law if you're not done law. What about accounting? A lot of accountants. Ifanya accounts. Walianza kuosha wakaonyeshwa debit credit kwa system and now they can do very well. Though in that case inawasumbua kidogo though they can be able to do. Ni kweli ama ni uongo? We have section 1, section 2. They can act as a chief accountant. Ama yes, it's not about the education level. Gender. That cannot, because we are manager, it must be a guy. Level of responsibility. It's not. We have some people actually, you see, for people who like are running, they require the job which challenge them. Ni ukweli? So ukiwapea kitu, if you are given a job to be a cashier for 10 years, will that motivate you? No, unasemanga, hii kazi nimefanya sana. Why don't you wait to go to the account department? Yeah, the level of responsibility. Then the number of years in service. Actually, what happens? If you enter into the job market, you are highly motivated. Ukweli ama uongo? With the time, you develop what you call the doctrine of iniquity. You know what's the doctrine of iniquity? Unaona kama unasaidia employer sana. You compare what you are doing against what you are getting. That's what we call doctrine of iniquity. And from there you start, you see in that case, but we have, so the number of years of service does not determine what? Then a lot of job satisfaction. Good. That was number C. If you get your 7 marks plus the rest, siko sawa. Now let's go to part D. What's part D? Coefficient of determination, and you comment? D, coefficient of determination, that's R squared. How do we get R squared? Don't bring that formula here, R times R. In this case, actually you have more than one independent variable, but you can also use R times R. So you have to use explained variation. You divide by the, yes, and then you might be knowing the formula. But the problem is that, do you know what explained variation represent? It represent what? Regression sum of square. You divide by the total sum of square. Now let's go to the Anova table. In the Anova table, we have sum of square. Are we there? You take the regression sum of square, which is 151.25. You divide by the total sum of square. That replaces the variation. 294.4. Can someone give me that? 0.52. You are told that you computed, you interpret. Who can help you interpret that? Hey, let's try to interpret that. 52% explains what? I never said that. What does it mean? Now, I want you to put that in a good statement. Yeah, stop from that point. That's what I wanted. Are you together? That 52% of the level of job satisfaction is explained by the above 7 variables. Are you together? It's only that 52% of the level of job satisfaction is explained by the above variables. Or you can also say that 52% of the above variables explains the level of job satisfaction. Good. Then in that your handout, there is assignment. I have given us an assignment 3. For those with the notes, do you have that? Yes, there is assignment 3. That's all about remembering. What is sum of square? How do we get mean of square? Etc. So I don't know if there was a latest question from, yeah, there was a latest question from the past paper. Eh? Yes, open that question. July 2014, I mean 2017. Ah, good, I found the question. November 2016. You're still looking for July. So you can take a screenshot of this before I rub it. But you already have it in the note. So November 2016, question 2C. I want you to discuss that with your neighbor or your friend at home for the next 1 minute. November 2016, question 2C. Just go through the question. How long can it take to answer that? Yeah, those are 10 marks. Now let's start with question 2A. Highlight for application of Markov analysis in business. Application of Markov analysis in business. CVP analysis. Human resource. Yeah, education institution to determine the transition of students. Yeah, financial accounting to predict the bad debt. Marketing and advertisement to determine the movement of the customer behavior, to study the customer behavior. Yeah, in financial forecasting. Number B. Do you do that in class? Yes, that's a theory. Then you go to part C. The following data shows result of a regression learned on variation in labor cost as a function of labor hours. Labor cost is our Y. Are you together? As a function of labor hours. So labor hours is our independent variable. So you are given the regression statistics, R squared. What is R squared? What's R? No, I'm asking not how to get R squared. What's R squared? Coefficient of determination. Are you together? Then we have multiple R. Multiple R is the normal R. Correlation coefficient. That's R. Then we have standard error. Observation was 24. That's our N. Good. Then you are given the Anova table. We have degrees of freedom, sum of square, mean square, F ratio, significance F. Then you have the coefficients, standard error, T statistics, P value required, the missing value. So I want us to get X1, X2, X3, X4, X5, X6, X7. We start with X1. X1, they want what? R squared. And you see that to get R squared, you take X plane variation over total variation, which is the same as regression sum of square over total sum of. Now let's go to the Anova table. Can you see regression sum of square? It's X, X3. So first of all, let's answer X3. Who can give me what's X3? You should be through by now. X3 ni ngapi? Ni ngapi? Boy, if you are thinking you don't know what you are doing, hapa hakuna kitu ya kufikiria na hakuna kitu ya kucompute. Wow. We are looking at X3. Hiyo tu nataka peke yake. 20? Very wrong. It's not 24. Now, it's what? Good. It's 1. We say that represent the number of independent variable, or alternatively, hebu tuende hapo. Tuko na X3, we have 22 and we have 20. This is regression sum of square. I mean degrees of freedom. This is residual degrees of freedom. This is total degrees of. We say that if you take that plus that, you get what? You get the total. If you take 23 minus 22, this one, maisha ilikuwa ngapi? It was 1. And then you are told that, na nimesoma na nikamwambia, the following data shows the result of regression learned on the observation of labor cost as a function of labor hours. How many independent variables do you have? 1. That's what we are looking at. Hebu mjaribu kufanya your vitu ziwache kuwa ngumu. Because that's how you're conditioning your mind. It's not something hard. Ni kitu tu ya kufikiria. Yes, because naona mnafanya exam next week. Now say it's like you are new to the course. It's like I'm teaching. Now we can go to R squared. We already have regression sum of square, which is regression sum of square. We don't have. How much is it? 0.029. You divide by the total sum of square, which is 0.04. What do you get? 0.725. Who can interpret that for me? In case you are taught to interpret that. That's coefficient of determination. Good. 72% of labor hours explain the labor cost. Now let's go to X2. X2 is what? Multiple R. We have said that multiple R is the same as R. So you get just the square root of 0.725. Give me the coefficient of correlation. 0.8514. Who can interpret that for me? Very wrong. There is a strong positive or direct correlation between labor cost and labor hours. Are you together? Good. X3 we already have is 1. Let's go to X4. X4. Haraka haraka. X4 ni ngapi? You're getting what? How do you get X4? (0.00) divided by, very wrong. I don't want you to think actually. This question is straightforward. Can someone volunteer? Are you getting 0.011? Good. Try kurudia hiyo. If you take regression plus residual, are you not getting total? In this case, you have, now let's be here. It's 0.04. Are you together? You deduct what? 0.029, and you're getting 0.11. In that, if you take the regression sum of square, you add residual sum of square, you should get total of 0.04. Very easy. Let's go to x phi. X phi is f. We see that, how do we get f? Okay, before we go to f, let's go to mean square. This is where you have the mean square. We see that, how do we get the mean square? The same mean square, you take, for example, for regression, you take regression sum of square, you divide by regression degrees of freedom. That's what we are doing. Eh? For example, x3 is what? X3 ni 1. So I want you to take this. Sum of square for regression is how much? 0.029. You divide by degrees of freedom, which is 1. What do you get? 0.02? That's how you get it. I'm trying to take you back. We are still doing revision as we answer this question. But in this case, I want x phi. X phi ni f. Na tulisema to get f, you take regression mean square over residual mean square. Regression mean square is 0.029. You divide by 0.00045. Give me that. 64.4. Good. Now let's go to x6. X6. Now, when you go to the table of coefficient, what comes to your mind is your formula. How to get what? T. And how do we get T? B over SB. Now, x6, what do we need? Now, let's go where you have the coefficient. We say that coefficient means what? Yeah, I indicated what B means. B means coefficient. So can you write that? Where you have the coefficient, write it B. Then you have the standard error, write SB. Good. Now, in this case, we need x6. So that means in this, what is required there? SB. So that means if we need SB, you already have T. How much is our T? 11.328 is equals to B. We must be having B 0.077. You divide by SB. So to get SB, you take that, divide by that. Eh? Good. What do you get? .00. Good. Let's go to x7. X7, that's T, right? And T, you take B. How much is B? 0.826. Are we there? You divide by SB, which is 0.103. And that's how you get your x7. What do you get? .0? Good. Number 2. That's how you get your 7 marks. Is it hard? It just requires some little revision. Eh? Yeah, just go and master. What do we mean by regression sum of square, degrees of freedom? How do we get mean square? If you are good in that, that requires just 10 minutes to get it or to cram it, eh? Which is the easiest. But as a smart student, you don't have to cram it. Even you can be able to derive the formula from what you are given. I can be able to get the formulas from what I'm given there. If you forget, just try, because there is one which is complete there. Eh? You don't get what I'm saying. Eh? Now let's go to part 2. A 95% confidence level of the labor hours worked. How do we get confidence level for T? Confidence level, that means it's either plus or minus. We are trying to get what we call the margin of error. So you'll be taking 1 minus alpha over 2 n minus 1. Alternatively, you can just ignore 1 minus alpha. Eh? Just take alpha over 2, because under the T table, they give you the same solution. Can you go where you have the T table? Let's go where you have the T table. Now, this is what I mean. If you are to get 95%, this is what I'm trying to use, which is the same. If you're given a confidence level of 95%, that means the significance level is how much? 5. That's what I'm saying. Instead of taking 1 minus alpha over 2, you can also take alpha over 2. Are you together? Yes, use the significance level instead of significance level. Then n minus, not n minus k. N minus k is when you are getting the t calculated. Are you together? N minus 1 is when you are getting the confidence level. So n minus 1, how much is n minus 1? It's 23. It was 24 minus 1, you get 20? 23. So alpha is how much? 5, because we are to be 95% confident level. It's 5 over 2, and then you go where the degrees of freedom is 23. So it will be plus or minus what? Go to the T table. Yeah, actually, we are given that table. Can you see where you have 0.025 or 0.05? Is the same as doing this. I want you to do this. Alpha over 2 you get 0.02. 1 minus answer you get 0.975. In the same line, can you see that? T is equals to T.0975. Yeah, that's what I'm saying. Either the case, they give you the same answer. And you're getting how much? You go over there, have degrees of freedom of 23. 23. 2.06 now. Good. As simple as that. So make sure if the Anova question comes, even if you don't get all the marks, you get at least 90%. 90%. Good. And that marks the end of that class and session.